Hi, I'm Dave Mueller, retired hydrologist from the U.S. Geological Survey and founder of Genesis Hydrotech. In this session, I'm going to present what I believe are the best practices for making ADCP discharge measurements. These practices are consistent with the procedures required by the U.S. Geological Survey. When collecting data, it is good to think that if someone were to challenge the quality and accuracy of your data, that you could defend that data based on the procedures you use to collect it. Preparation in the office is key to successful data collection in the field. First, consider the site conditions. The depth, is it shallow or deep? The velocity, is it slow, turbulent, or fast? The sediment transport, is there potential for a moving bed condition? What are your deployment options, a manned boat or a tethered boat from a bridge or tagline? These are important when making equipment selection. If the depths are shallow, you should consider a higher frequency instrument. If they are deep, a lower frequency instrument may be better. For velocity, this is primarily a deployment issue. You need to pick a deployment that will be stable in the velocity conditions present and will avoid air entrainment under the transducers. If there is potential for a moving bed, a lower frequency ADCP performs better in moving bed conditions, and a GPS should be used as GPS is better than a moving bed test correction. Equipment preparation. Check that all equipment is working properly before leaving the office. It is much easier to troubleshoot problems in the office rather than in the field, where the weather may be bad and communications with someone to help may be poor. Your field computer. Does it have the correct software version? Check the communication with the ADCP and GPS. The serial ports are Bluetooth. The cables and any data radios if used. Verify communications before leaving the office. Run an ADCP diagnostics test. Check the ADCP clock. Check that GPS data are being received properly if it is used. Check your batteries and make sure your batteries are charged, and always take a backup. Also, always take a direct connect cable even when using data radios if your ADCP allows a direct connection with a cable. Next, field preparation. Before you begin collecting discharge transects, it is important to follow these pre-measurement steps. Set up the ADCP, measure the ADCP draft, configure and check communications, set the ADCP time, run a diagnostics test, calibrate the compass, verify the temperature, locate and select a good cross-section, and complete a moving bed test. We will discuss each of these in more detail in the next slides. At the site, the first step is to set up the ADCP, which will vary based on your deployment method. The ADCP should be mounted and cables or radio modems attached. I always recommend attaching a safety line to the ADCP, both on a manned boat and when using the tethered boat. Once everything is connected, attach the power supply and ensure that the unit is powered. Always measure the ADCP draft, which is the distance from the center of the transducers to the water surface for TRDI equipment, and the distance from the bottom of the transducer to the water surface for a Sontec ADCP. On a manned boat, ensure you account for the roll of the boat as the hydrographer reaches over to measure the depth. Many offices will mark the mounts or tethered boats with survey tape to allow the transducer depth to be read easily. Next, configure the communications. Set the communications with the ADCP. The steps and dialogues to do this will depend on the ADCP software and method of data collection. This may include setting up an external GPS or heading sensor. Note, this should have been tested prior to going in the field and should be very straightforward when you get to the field. Next, set the ADCP time. Again, the exact method for doing this will depend on the manufacturer and software used. In Wind River 2, the Set ADCP clock may be found under the Acquire menu. It opens a dialog and provides you two options: using the current PC time, or using GPS time if GPS is connected. For River Surveyor Live, the Set Time option is on the Smart page. For RSQ, the time can be set under the Tools and Settings dialogs. It can be set to the local PC time, the GPS or UTC time, or the data collection time zone. Run a diagnostics test. Again, this will vary depending on the instrument and the software that you're using. The specifics of this test will be discussed in another video. Calibrate the compass. This is particularly important if you're using GPS or you're going to use a loop moving bed test. The methods to calibrate the compass for each of the instruments will be discussed in a separate video. It is best practice to obtain an independent temperature reading to confirm the water temperature read by the ADCP. Incorrect water temperature readings can bias your data, so it is important to check the temperature before data collection begins. To verify the temperature, put the ADCP in the water and give it sufficient time to equilibrate to the water temperature. Start the ADCP pinging without recording, then measure and record the independent water temperature and salinity. You should verify that this independent temperature reading is within 2 degrees of the ADCP's temperature measurement. The temperature and salinity should reflect the values at the transducer face. This is where the Doppler shift is measured. The mean temperature and salinity in the water column will affect the measured depth, but typically streams are well mixed, and the change in water temperature and salinity from the water surface to the stream bed will not introduce substantial bias in the depth measurements. In Wind River 2, the ADCP measured temperature can be found in the composite tabular window. For River Surveyor Live and RSQ, the temperature may be displayed in the table at the left of the software. If the temperature is not displayed, you can right-click on the table, select System, and then check Temperature. Finally, locate and select a good cross-section. Although you can measure almost anywhere with an ADCP, it doesn't mean you should, or that you will get a high-quality measurement. Don't underestimate the value of a good cross-section. Locating a good cross-section is one of the most important considerations for making an ADCP measurement. A poor cross-section can be the limiting factor when it comes to collecting consistent quality data. An ideal measurement location would have uniform flow conditions with no rapid changes in depth. It would allow for 2 good depth cells on the edges while still allowing for minimal unmeasured area at the edges. If you are unsure about the quality of the cross-section, it is always worth collecting a test or probing transect to evaluate the velocity and depth conditions. Complete a moving bed test. Moving bed tests will be covered in another video. Now you are finally ready to collect transects for measuring discharge. The starting point for a transect should typically have 2 good depth cells to allow for adequate estimation of the edge discharge. Once the boat is in location, measure and record the distance of the ADCP to the bank. When the operator is ready, start recording edge data and hold the ADCP in position for a minimum of 10 ensembles. After edge data have been collected, move the ADCP across the river, keeping the boat speed less than the water speed when practical. More importantly, be a smooth operator. Consistent speed and direction is more important than going slow. During data collection, the computer operator needs to continually evaluate the data being collected. Are the navigation references valid? Is the ADCP in boat stable? Is there excessive pitch or roll? If so, what can be done to reduce it? Is the water track data valid? Is there any evidence of separation in beam intensities that may be caused by air on the transducers? When using GPS, the compass is important. A good check on the compass is to ensure the flow direction is consistent for reciprocal transects. Are the depths valid? Do the depths represent the expected cross-section shape? When nearing the ending edge, approach slowly and hold the boat in position for a minimum of 10 ensembles to collect data that will be used to compute the edge discharge. Stop recording ADCP data and measure and record the distance from the ADCP to the shore. Repeat this procedure for a total of 2 transects, or more as needed. The minimum exposure time for a measurement is recommended to be 720 seconds, which only includes the sampling during the transects, not the time between the transects. Also, in addition for collecting for 720 seconds, the transects must be collected in reciprocal pairs. There should be an even number of transects with the same number collected in each direction. The measurement discharge is the average of all valid transects. Exceptions to these recommendations may be necessary when measuring in rapidly changing flow conditions or in extremely low flow conditions. When using Auto Edge in River Surveyor Live or RSQ, the procedure is the same for Wind River 2 until the end bank is reached. F5 to start recording. The Edge dialog opens. Wait at least 10 ensembles. Select the correct bank. Select the correct edge type. Measure and record the distance to the edge. Then, move across the stream, collecting ensembles, paying attention to the data. Stop at the end edge. When the end edge is reached for Wind River 2, wait at least 10 ensembles, measure the distance to the edge, and press F5 to end the recording. The transect ends, the edge dialog opens. Select the edge type and record the distance to the edge. When the end edge is reached for River Surveyor Live or RSQ, pressing F5 starts the end edge data collection. The edge dialog opens. Wait at least 10 ensembles. Select edge type, measure and record the distance to the edge, and close the edge dialog. The transect ends when the minimum number of edge ensembles are collected or the dialog is closed, whichever comes last. You have completed the measurement, but you're still at the site. Don't pack up and leave yet. Process the measurement as completely as possible before leaving the site. Doing this allows you to identify problems that could be corrected, repeat the measurement if necessary to correct errors, or collect another measurement to validate the first measurement, often called a check measurement. It is recommended that QRev or QRevInt be used for on-site processing. QRevInt automates most of the quality checking and provides caution and warning messages. When you review the messages, it is good practice to include comments regarding the messages. Finally, save the measurement. USGS practice is that if the measured discharge is more than 5% different from the rated discharge, and there is no obvious reason, such as a change in the control condition, then a check measurement should be made. For a check measurement, change as much as possible. The equipment, an ADCP, flow tracker, or price meter, the method, moving boat or midsection, the laptop, the deployment, the cross-section, the configuration, the operator, as much as possible. If the check measurement is another ADCP moving boat measurement, repeat all the pre-measurement steps: ADCP test, compass calibration and evaluation, and moving bed test. Create a temporary backup before leaving the site and store separately from the computer. Should an accident happen at the next measurement site and the computer and/or backpack ends up in the water, you don't want to lose your previously collected data. When you get back in the office, follow your agency-specific policy. However, it is recommended that you archive the measurement files to a server and enter the measurement into the agency database. It is best practice to have someone review your measurement, especially if you're a new user, the measurement was in difficult conditions, and/or the measurement is critical. Now is the time to maintain your equipment, make repairs, and replace broken or missing parts. Get the equipment ready to go for the next measurement. Following these best practice recommendations will help you collect quality ADCP measurements.